Plastics is today a problem. Some of the plastics we incinerate, some of the plastics we put in our landfills. A small amount we recycle, but a huge amount ends up in our oceans. Listen to Martyna Solis. She will talk about the possibility to recycle parts of the plastic that not is recycled with chemical recycling. She is a PhD student at Technical University of Denmark. And now let's deep dive into one possibility to create the value of plastics.
Thank you very much. It feels a bit weird to speak English, but I would try to do my best. Usually I speak Swedish. So yeah, my name is Martyna Solis. Thank you for a warm welcome. Today I have two hats on me. I represent both Technical University of Denmark, where I am a PhD candidate currently, but also Profu, that's independent research and consultancy company here in Sweden, where I'm taking a pause right now to do a PhD. And today I will be speaking about chemical recycling. I will show you some examples of the projects that me and my colleagues have carried out in the past that are relevant in this context, and what we are working on now, and what I think are the important takeaways to have in mind for the future. So the agenda for today is that in 3 parts in very short words. First, I will be speaking about why is chemical recycling important, why do I think it's relevant, how far have we come in research so far, and what seem to be the next steps or next questions to have in mind. So to start off, here in Sweden, a lot has been happening in the plastic recycling sector. First with the legislation that comes from above, with EU strategy for plastics and circular economy, where new requirements on the recycling process and recycled content in material is determined. But also on top of that, the Swedish goal of becoming fossil-free nation by 2045, where one of the big questions or one of the big challenges is actually the fact that still a lot of plastics in residual waste is sent for incineration, and that is a limitation in terms of reducing the emission that Sweden has as a country. And here we see an increased interest in sorting out the plastics that today is in residual waste and do something else with it instead of sending it for incineration. However, today there are limited options in terms of what to do with that plastic, because it usually often has lower quality and may be challenging to be sent for mechanical recycling. So there is a clear need for new technical solution that will help to tackle that issue. This is the current system in Sweden for recycling of residual waste. And I wanted to show you, do you see what you see what I'm pointing at. We're starting with the design, then we go through production, distribution, trade, consumption, collection. This is obviously a simplified system. However, there are 2 options for plastic and residual waste. Either it can be sorted out with near-infrared technology or not. In the first case, some of the plastic can be mechanically recycled, and the rest can be sent for incineration directly. And in case it's not recycled, obviously everything gets incinerated straight away. The plastic fractions that are today a challenge for mechanical recycling and also challenge for increased recycling rates are first black plastics that's not possible to be recycled, then 2 small plastic pieces that are just not possible to be traced, and then the plastic that's too contaminated or too dirty to be recycled. And those 3, more or less, prevent the plastic loop to be closed completely. And in that context, I would like to start speaking about chemical recycling. So first, let's take it from the beginning. On the top, you see a very simplified process diagram of mechanical recycling. Here I wanted to show that plastic that's recovered by mechanical recycling doesn't have virgin quality, which means it cannot be used with the same application or for the same application as the input material. And this is where chemical recycling can theoretically help to overcome that limitation, because here it helps to produce virgin quality materials, close plastic recycling loop to a greater extent that we have today, and also has higher tolerance than mechanical recycling for contaminated and mixed plastics. But what do I mean by chemical recycling? This is a name that is an umbrella name for a lot of different technologies. Here I will use the example of pyrolysis, which is a process under high temperature, around 300-700 degrees, and special conditions, in this case without oxygen, plastic polymers are broken down into shorter chains in order to come back to that higher quality. And that is why the process is way more energy and cost intensive than mechanical recycling, because this willingness to come back to the virgin quality comes at the price of energy and is much more expensive. So if the technology is so great, I guess all of us thinks that why don't we have it up and running yet? Well, so there are a couple of limitations to that. And what we have done so far, so together with my colleagues at Profu and some other actors that we have teamed up with, in 2020 we started a project with aim to try to answer the question how chemical recycling could be implemented as a complement to mechanical recycling here in Sweden. Why is the word complement underlined? Why is it important? This is because, at least in the Swedish context, mechanical recycling is very well established technology. It's more cost and energy efficient than chemical recycling, and therefore it's considered to be more suitable as a base. So in order to tackle that challenge and in order to try to answer that question, we have invited actors along the plastic value chain here in Sweden to come and be part of our reference group so that all the perspectives are in place. And discussing with them and working together with them, and also the analysis gave very interesting takeaways. And before I start with the conclusions, I just wanted to say that bear with me, because I'm trying to summarize 1.5-year project in one slide. So I will not go into too many details, but if you have any specific questions or want to know more, you are very welcome to send me an email or ask me when we have a break. But just in a very big shortcut, we were looking into 3 different technologies, 3 potential locations for a chemical recycling plant in Sweden, and 2 time perspectives. In the short term, we were looking only at pyrolysis because this technology is more suitable for small scale and seems to be more probable to be implemented in commercial way than the rest. Yeah. In the short term, our takeaway was that if chemical recycling was to be introduced in Sweden, it seems from an environmental and circularity perspective that it seems the most beneficial to have it in Stenungsund, which is in the west coast, and that's because chemical infrastructure is in close proximity there. That makes it easier to connect the process to the refinery that would potentially take the pyrolysis oil and turn it into plastic products. Then in the long term, where we were looking at pyrolysis, but also some other technologies like gasification and steam cracking that are potentially offering higher or more detailed polymer breakdown, but also require larger scale and higher costs and higher energy requirement, then we found out that from circularity environmental perspective, steam cracking seems to be the most beneficial one, and also, like before, in the West Coast. And the value chain analysis that we have carried out showed that if chemical recycling was to be introduced in Sweden, then there would be 3 new actors in the value chain. So first of all, the supplier of chemical recycling technology, that's not a surprise. But then the owner of the chemical recycling plant. And here we have found out that it doesn't necessarily have to be a technology supplier. It can be potentially any actor in the plastic value chain. There are different constellations that are possible. And then the third one, the transportation company that's responsible for all the additional logistics that would have to be added to the system. And then the project, as it usually is with research, one question wakes 3 other questions. That was like that in this case. We have found out that there are many different problems or issues that also need to be addressed. For example, the quality. So what is the quality of the product from pyrolysis versus what's the standards of quality of chemical companies that will potentially take the product, or what can actually actors in the value chain do together to make this introduction smoother. And we tried to address some of those questions, and we had a follow-up project in a little bit of different constellation with the overall goal of trying to determine what potential does chemical recycling have to contribute to fossil-free incineration here in Sweden. And going directly into the results, we found out that looking at the Swedish case, chemical recycling has actually limited potential to take care of plastics flows that cannot be recycled mechanically. Again, we were looking at chemical recycling only as a complementing technology to the system that we have today. And with the assumption that all the plastics is sorted out from residual waste, we found out that the maximal potential is around 30%, so not that much. Then the second takeaway was that the competition for feedstock between those 2 technologies is real. Both of them require clean or pure streams with high polyolefin content. This is the case today, but it can change when chemical recycling technology is further developed. And then the last one is that the balance between those 2 technologies in the system will be difficult to reach unless new collaborations and increased information exchange is started in the value chain. So here again, it's very important that the value chain works together on that. And then research is one thing, but I wanted to quickly just show you what happens in reality. Are there any chemical recycling facilities out there in Europe, at least on a commercial scale? Well, the answer is yes, there are. And here with the yellow dots, I have marked either commercial projects that are already up and running or the ones that are planned in the planning phase. And you can see clearly that most of them are either in Western Europe or in the Nordics. So if you're interested in knowing a little bit more about that, I will leave it like this for now, but I'm very happy to discuss. So what is next? What are the questions that still are to be solved or still are to be addressed, and what are we working on now? So as I mentioned right now, I am a PhD candidate and right now working at the Technical University of Denmark, and together with my colleagues there, and also a consortium of 17 different partners that you can see on the left-hand side. We got involved in a project that's called Circular Industrial Plastics. That's a response to the fact that a lot of research around chemical recycling of plastics is currently made on the packaging. but there is limited knowledge on how the potential looks like for plastics that's not municipal or not from households. And the project is supported by the Danish Environmental Protection Agency, and it's a so-called flagship project, which means that the recycling waste that we're going to look into in the project are going to be tested and demonstrated on full scale in order to inspire Danish industry. So the objective with the project is to demonstrate new paths for plastic materials from 3 different industries: technical, medical, and consumer. And the DTU's role in this is to carry out environmental assessment of recycling technology in different cases that we will also formulate within the project. If you're interested in knowing more about it, I left the link here. So there is a lot of information that's public in the internet. And then, as I mentioned before, the scope of the project is purely Danish, and it's going to last 2 more years. And then another example of the project that we are working on right now is the textile project. I know that the topic of today's presentation is plastic, but I would feel that I'm missing something important if I don't mention textile today. Many people consider textile to be new plastic challenge, a new hot topic, a new problematic fraction that no one really knows how to treat. And together, my colleagues and me at DTU, together with a joint research center under European Commission, work to look into the bottlenecks and limitations of current textile recycling system, and to look into what would be the environmental impact of different technologies, so current that we have today and also future that have a big potential, in order to organize textile recycling in Europe in a better way. Because as we know today, the system is suboptimal. The recycling rates for textiles are very low on the European scale. And again, the methods that we're going to use, similarly as in the previous case, will be material flow analysis, life cycle assessment, and the project lasts for 1 more year, and the scope is European. Before I leave, I wanted to send you some 3 closing remarks, so that if there's anything you should remember from this presentation, these are those 3. First of all, that chemical recycling is an important part of the solution, but it's still only part of the solution. It's not a silver bullet that's going to solve all the plastic problems that there are out there. It is one of the measures that should be taken together with, for example, working with the plastic design or working with plastic prevention. Another one is that chemical recycling is considered to be best complement to mechanical recycling, and that's for the reasons I mentioned before. Mechanical recycling, at least in the Swedish context or context of the countries where mechanical recycling is working well and is established and cost efficient and energy efficient technology, those 2 doesn't seem to be beneficial if they compete with each other. And then the last one is that technology development is one thing, but success of chemical recycling in the future will be determined by other factors that are sometimes overlooked. For example, energy consumption, contribution to circular economy, cost, and so on. So that was all I wanted to say today. Thank you very much, and feel free to send me a question if you have any. Thank you.
Thank you so much. I do have some questions. When you mentioned Stenungsund in 2025, you also had in brackets Motala. Please, what is happening in Motala, so that everybody knows?
Yeah, so the reason, I have to stand back. The reason why we were considering Motala, we were considering 3 different locations. One was Stockholm, one was Stenungsund in the west coast, and one was in Motala. That's because in Motala, as we all know, there is Svensk Plaståtervinnings sorting facility for plastic. So we thought it makes sense if the chemical recycling facility was in close proximity, so that the transportation of waste is not that extensive. That also has, all this transportation has impact on the environmental load of the solution. And that from the numbers that we got, it was actually purely environmentally speaking, that was the most beneficial solution. But after talking to the reference group, we found out that the chemical industry proximity seems to weigh the actual most beneficial alternative more towards Stenungsund in this case.
And you said that only about 30% are possible to use today from what's sorted out from Motala, is that correct?
Not only from Motala, we were looking at the rejected stream from mechanical recycling, but also the plastic that could be sorted out from residual waste. Yeah. So if we took all the plastic that is not sent for mechanical recycling in Sweden, maximum 30% of that could be mechanical recycled. That's what the analysis showed.
There's a high trend when it comes to trying to source from the plastic flows, and one of the big trends is to make sure that I would like to have the cleanest fractions, like the PET, but we all know that PET is already a circular system. So that is, I believe, it's important not to crash current existing circular flows. Make sure that you recycle from other source. Do you see any trend there when it comes to you also mentioned there was a big competition today about the sources.
As I said during the presentation today, there seems to be a competition as it comes to feedstock. And that's something that all the researchers and people that work with try to somehow cope with or balance out, so that the facilities that are planned or ongoing are somehow taking that into account, so that the system in its overall shape is balanced and functions well together, so that the technology do not work against each other, if that's what.
Yeah, exactly. In 2019, Ragn-Sells and Easy Mining was invited by the Swedish ambassador in the Netherlands, because all the Nordic countries held a circular economy session there. And so after my presentation, I was approached by British Petroleum. And they asked me, we would like to collaborate with you, we would like to have plastics. And I asked them, how much plastic do you want? Well, we would like to have every single plastic from Sweden. Okay, that would be a challenge. So I truly agree, we do have a challenge when it comes to the feedstock. Dag, you raised your hand.
Yes, Dag Newberg from Target. I have a question about this. You said it was 30% that could be recycled. Is that because of capacity issues on these plants that they, or is it more technical issues like the remaining 70% is from technical reasons or something not possible to do chemical recycling?
We were in the project, actually the whole report, if you want to know all the details, it's public and it can be read on Affärsverige website. But just to give a short answer, we were looking into the estimation of what the rejected flow looks like, what fractions are inside, and we compared it with the wished composition of the feedstock for chemical recycling, and we found out that many of them just don't match. Many of the fractions that you see in the rejected stream just cannot be used as a feedstock. And also we were looking a little bit in the future, because we see with the increased sorting investments in Sweden that it's very likely that some of the fractions that we have today will actually disappear because of increased sorting or because the design is better. and what impact that would have on the feedstock availability. So we considered those two things mainly.
Are there any other questions that someone would like to raise? I don't see any hands. It's very dark here. So thank you so much, Martina.
Thank you.
We'll make sure you will be here all the time and during the break, and we'll be able to maybe ask some complimentary question in the end. Thank you so much.